Woohoo! It's finally time to learn our very first data structure, and one that most likely you're very familiar with. Arrays. Arrays, which are sometimes called lists, organizes items sequentially. That means one after another in memory, kind of like we have here. We have some sort of data at index 0, let's say juice, and then right after at index 1, we have something else, maybe apple. Maybe this is a grocery list. In our computer's memory, it'll be one after another. Because remember, our RAM is a lot bigger than just 7 slots. And arrays are probably the simplest and most widely used data structures. And luckily for us, we're starting with this because arrays have the least amount of rules. And because they're stored in contiguous memory, that is, in order, they also have the smallest footprint of any data structure. So if all you need is to store some data and iterate over it, that is, go one by one, step by step, arrays are the best choice. Especially if you know the indices, that is, here on the left, of the items you're storing. And just as a quick glance, and we'll go over this in more detail in later videos, but lookup or access with arrays are constant time of 1. It's super fast. Other actions or methods that we're going to go over, such as push, are also fast, but then inserts and deletes are O of n, or linear time. But in order to demonstrate arrays, let's actually use code to show you an example. We have our little playground over here. And again, you can use whichever language you prefer. I'm just going to demonstrate this in JavaScript. We can create a simple array. Let's call it strings. And this array, again, using the square bracket notation, will have A, then B, then C, and D. And we've just created an array in JavaScript. Now, looking at this, and based on what we've learned so far, we can make a couple of assumptions. For example, to store the letter A, letter B, letter C, letter D, that's 1, 2, 3, 4 items. If we were on a 32-bit system, that is, we have 1, 2, 3, 4 shelves to store the letter A in zeros and ones. Well, if that's the case, we just multiply 4 times 4. So 4 items, and each item taking up 4 shelves in our memory. That means we're using up 20 or 16 bytes of storage. If we remember in our little example here that with a 32-bit system, we have 1, 2, 3, 4 shelves to store this number. Again, this is a bit of a simplified version of looking at it, but I hope you see what we're doing here. We're simply storing A, B, C, D in sequential order in our RAM, our random access memory. So the computer now knows where to find these items. Therefore, when I do strings 2, I'm telling the computer, hey, go to the array called strings. You should know where that is because underneath the hood, you stored it for me. And grab the third item. Remember, the indexes are 0, 1, 2. So grab the third item from where the array is stored on your memory. And if I run this, I'll get C. The computer is going to grab that information for me because here it stored it for me and here it's grabbing it for me. All right, so let's do a few more operations with arrays and see what the pros and cons are. Well, in JavaScript, we have a few methods that we can use with arrays. One is push, which simply allows us to add something at the end of the array. So strings dot push E And if we just remove this, and let's have a console.log of strings. If I run this, I get A, B, C, D, E. This string push operation, because it just adds it at the end of the array, is an O1 operation. All we're doing is adding whatever item we want at the end. We're not looping through anything. So hopefully that makes sense why that would be O1. That's very convenient. What's another method that we get? We can also use pop. And pop is the opposite of push. Pop will simply mean to remove the last item from the strings, from the array. If I click run here, you see that the E was moved. If I do strings.pop again and hit run, we see that this time around we've added E, then we removed E, and then finally D to be left with A, B, and C. What do you think the time complexity of this operation is? Once again, it's O of 1 because we're not looping through anything. We're just removing the last item. And remember, our computer knows where last item is stored. We're simply saying, go to index of, let's say, 7, the very last item, and remove the bread. But let's do something interesting here now. What if we want to add an item at the beginning of the array? Maybe in here we want to add the letter X. Well, we have something called onShift in JavaScript. And depending on your language, you'll have perhaps something different. But the idea here is we simply do strings.onShift. And by the way, you see here how REPL.it actually gives you the parameters that you can enter. In this case, it just says what items, which is a string, should I enter. In our case, I'll say I want to unshift X, which is saying just add X at the beginning of the array. If I click run here, we see that X has been added at the beginning of our array. What do you think the time complexity of this operation is? And by the way, as we go through data structures and because we know big O notation, isn't it pretty cool that we're able to think about code beyond just, oh, I'm just doing this. We can think deeply about what's happening underneath the hood. Why might this operation be longer than this operation? I find that fascinating. And when I first understood this point, it really made me a better engineer. And I hope you're starting to get this aha moment for you as well, especially if this is your first time with data structures. Now, on Shift, what are we doing here? Well, remember, strings are essentially stored. If I move this to a new line, the computer knows that this is at 0, this is at index of 1, this is at index of 2, and this is at index of 3. When I add X with the unshift, I'm all of a sudden adding X into our array, but we now have to shift these numbers because the indexes are still like this. But this time around, we have to say, okay, 0 is now at X, A is now 1, B is now 2, and C is at index 3, and D is at index 4. And just by me doing this, you might have seen something. We just iterated, looped through everything, and reassigned the indexes. And I did 1, 2, 3, 4, 5 moves, or 5 operations to realign the indexes. And this should give you a hint. That is, this operation is O of n. Depending on the size of the array, that's how long it's going to take to do that operation. We're looping. So right away, we know that, with arrays, maybe it's not the best data structure for adding items at the beginning of the array. what if we wanted to add something in the middle of the array? So we can use the method splice here. Let me scroll down a bit. And with splice, I can say strings.splice. And again, I get a hint of what I can do. The first is the start number. So I want to start at index of 2. And remember, we have this array here, x, a, b, c. So we're starting at b. And the second parameter is the delete count. What do we want to delete, or how many things from this index do we want to delete? In our case, we don't want to delete anything, we just want to add. So I'll say 0, and then the items that we want to add. So let's just add a string that says alien. Oh, and let's remove this x from our original array. That's better. Let's hit run, and there we go. We have x because we've unshifted, a, then alien, b, c. So splice told us go to index of 2, 0, 1, 2, where b was initially, and add alien instead of b and just shift things over. So what we've done here is, if we go back to our example, we have the x in our array, and we shifted these indexes of x and a are still the same, but we shifted b over and said, in here, I want you to add alien. And we now had to go over everything and say 2 for alien, we want 3 for b, 4 for c, and 5 for d. So what's our big O here? We don't need this comma. Well, our big O in this case, we did half of the operations because we changed half the array. We looped through half the array. So it would be O of n divided by 2. But remember, our rules when it comes to big O, we remove constants and simplify to just O of n. Worst case, it's going to be O of n operation. All right. I'm going to leave this for you so you can play around and try different methods on arrays. But I hope you understand how they work and how there's some good things that we can do, such as accessing the array that is O of 1 because it's, well, extremely fast. We know exactly where it is in memory. We can push and pop, but when it comes to unshifting or splicing or even deleting, because with splice we can even do deletes, that's going to be O of n. And if we go back to our chart, we should now have a better understanding of why arrays lookups are extremely fast. We know where they are. We know why push, adding at the end of the array, is extremely fast. But why inserting and deleting might not be the best or the fastest when it comes to arrays. But here's the thing. There's actually 2 types of arrays. And in the next video, we're going to talk about these 2 types. I'll see you in that one. Bye-bye.